My name is Nakong Teddy, Computer Science, year 3, Makerere University. And in this presentation, I'll be reviewing some of 5 research papers that inform our project about advanced computer graphics education content authoring for refugee accelerated competence-based curriculum. So my goal here is to show how these papers contribute to the building of advanced low-resourced multimodal AI systems that can create interactive story-based learning materials that are aligned with the CBC, especially for accelerated learning among the refugee learners. So the first paper I'm reviewing is the Open Flamingo, and this one, it replicates DeepMind's Flamingo model, but in an open source, all are more accessible form. So this paper, it focuses on standardizing all democratizing access to large multimodal models that combine both text and images. So the main problem it solves is that large vision language models like Flamingo, were previously closed and they required huge computational resources. So Open Flamingo provides smaller trainable versions and reproducible recipes for researchers while with limited compute. So its architecture is that it uses a visual encoder such as CLIP to extract image features that combines them with a large model that later processes both images and text tokens in a single autoregressive stream. So this allows the model to see images and talk about them simultaneously, at the same time. Then for our project, the Open Flamingo provides a foundation for building low-resource multimodal pipeline. So this means that we can fine-tune a smaller model and it can be able to understand both CBC text and even text or even visuals, and use a few examples like lesson prompts, all storyboards to teach this AI how to generate new learning content. So for instance, if we show the model a few examples of science storyboards, maybe about plants, it can learn how to generate similar ones. Hence, it can combine visuals and narrations. So this Open Flamingo sets the foundation for our project, but to enhance how deeply the model understands visuals, let us look at the next paper. So that is its architecture, the architecture for the Open Flamingo. So let us look at the next paper. The next paper is about the Kong LVM model. VLM model. So this one introduces an idea of a visual expert that can be inserted into an existing large model, language model. So the problem it addresses is that many models only combine images and texts at a shallow level. So they struggle with deeper visual reasonings, like interpreting maps or even diagrams. So about its architecture is that it integrates visual experts inside the transformer layer. That is one which has the attention and feed forward blocks for the language model. So it integrates that visual expert into the transformer layer. So this deep coupling means that the AI can reason about what it sees, not just describing it, but it can reason and tell more about what it sees. So for our project, this model approach is useful because CBC lessons often involve like visuals that require reasoning. For example, if a model is to interpret community maps, maybe explaining diagrams in science, or even understanding artistic illustrations. So it requires great reasoning. So that means that adding a visual expert model helps the AI model generate more accurate educational explanations from the images that are provided to it. For example, let's say a model like this could look at a photo of a village and generate a video, only a visual-based video about sanitation and community hygiene that matches the CBC learning goals. So now, since this AI can reason better with visuals, the next challenge you could look at is teaching it how to follow education instructions the way they are given to it all properly. And that is where the next paper comes in. That aside is the architecture for this called VLM model. So the next paper we're reviewing is the OTA. It's the OTA model. This one builds on an open flamingo, but for it introduces a special process called the in-context instructions. That is where the other issue of following education instructions as they're given all properly comes in. So the problem it tackles basically is that many model models don't follow human instructions very well. So especially when the instructions combine both images and texts. So OTA uses a data set called Mimic IT that contains interrelated examples of instructions with images and texts. So it also optimizes to train efficiently on a few consumer graphic processing units. Like this one makes it perfect for like low resource environments with low resources. So basically for our project, we can use OTA, like its instruction tuning. We can use its ideas to train the model to follow CBC specific prompts, such as, let's say you want to tell a model to create a story to teach maybe the water cycle to a primary 6 learner. So the model will learn to interpret the question and produce a coherent story with visuals and text, with both visuals and text. So teachers can give a few, let's say CBC aligned story examples of lessons, then the AI can learn to generate similar ones. Similar ones, let's say stories or activities, or even visual slides, but with limited training data, remember. So while this one focuses on instructions of the user, the next one, which is the chameleon, for it explores how to combine multiple modalities more tightly for unified storytelling. So for this chameleon, it takes multimodality a step further. So instead of like processing images and text separately and then combining it later, which we call a late fusion, for it presents both. It presents both at the same time from the beginning of the generation. So this early fusion design, it allows it to reason and generate across images, and also even code sometimes, but in one unified sequence, because it does it from the beginning. It handles all tokens together. So the model tokenizes image. That's what its architecture. It tokenizes images and data into one discrete token, and then trains a single transformer to process both images and text tokens together. So it gives a very strong ability to produce coherent mixed outputs. For example, documents that maybe contain both explanations and related images. So then for the CBC storytelling project, Chameleon's design is important because it allows the creation of complete lesson materials, not in bits, but complete at once, but in one pass. So like, for example, we could say generating a story related images with captions and even maybe coding examples, sometimes for the STEM lessons all together. So one example I could give here is that let's imagine asking a model to generate a grade 7 visual science story about the water cycle with maybe 4 pictures and explanations. So the model could output a unified visual narration, something teachers could use there and then, like in the class. So that's with the chameleon. Then finally, in order to handle longer, maybe educational materials like entire textbook, maybe recorded lessons, we then turn to the Gemini 1.5 model. So for this Gemini 1.5, it's first of all a Google multimodal model that is designed for long text reasoning. It can handle millions of tokens at once. It can handle very many things at once, maybe including hours of maybe a video or a long document. So the problem it basically addresses is that most models lose context. Let's say when they're dealing with large, sometimes continuous materials like books, recorded lessons, they lose context. So this model for it chooses a mixture of expert designs with efficient attention mechanisms. So, and memory retrieval models that also allow it to process very long multimodal inputs while keeping coherence. Let's say for the books and even the videos that we talked about. So for our project, Gemini 1.5's ideas can help maybe the AI understand, then summarize long CBC materials such as teacher training videos, or maybe an entire curriculum unit, and also be able to generate concise visual story-based lessons based on the long documents or videos that have been provided to them. For instance, a model could watch an hour, maybe workshop that was recorded, and it automatically produces a short illustrated storyboard, maybe that is summarizing the lessons or the lesson content in the video that it watched. So basically, these papers form a backbone of an AI-driven story authoring system that can generate culture relevant content that is CBC compliant, and also materials for refugee learners that are efficient, that are creatively done, and maybe at scale. So these papers could be of very much use to our project, and they will very well bring out inform us about the project that we're working on. That is all I had. Thank you.